In this short presentation, we will introduce the machine tool simulation that's available inside NX-CAM. This is often referred to as the Integrated Simulation and Verification, or ISV option. Machine tool simulation allows NC programmers to check their programs before sending them to the shop floor. This can reduce testing time on the machine tool and allows the programmer to optimize the machining process. Machine tool simulation can look impressive with advanced shading and other graphics. However, in most CAM systems, the motion of the 3D display models is driven off of the internal toolpath and not from the output of the post-processor. This form of basic toolpath-driven simulation is useful for simple review of a machining strategy, but is not complete or accurate enough for full NC program validation. To address this, many companies have purchased standalone machine tool simulation software to use outside of their CAM systems. The cost of purchasing and maintaining these separate third-party applications can be significant. It also requires data translation and the duplication of the entire machine setup as you work between the separate software packages. With NX-CAM, you have the option to use the fully integrated machine tool simulation. This simulation is driven by the G-code output of the NX post-processor. Also, there is no need to translate or duplicate data. It's all in NX. We refer to this as Integrated G-code driven simulation. Let's take a look at the use of machining simulation in NX-CAM. First, the user picks the machine tool on which he plans to run the job and selects that machine model from the library. The part can be transferred to an alternative machine at any stage. In this case, we pick a 5-axis milling machine with a Siemens controller. The programmer generates tool paths on the 3D part model from the wide range of machining options as we see on this complex impeller model. At any time during programming, the machining process can be reviewed using the integrated simulation capability. NX uses the appropriate post-processor for the selected machine and immediately prepares the G-code output to drive the simulation. You can check for errors, such as collisions or limit of travel violations. In the code display window, the user can opt to see either the internal toolpath data or the G and M codes from the post-processor output, all in NX. The machine tool 3D models are built using standard NX-CAD modeling functions. The Machine Tool Builder option allows you to add the full kinematics of the machine on the 3D model, including the axis, the limits of travel, and so on. The accuracy and completeness of the simulation is only as good as the software used to interpret the G-codes and convert this to 3D motion. For machine tools fitted with Siemens Cinemeric controllers, we can offer a special way to address this. NX-CAM can use software from the real Cinemeric controller to drive the machine tool simulation. With this option, the motion of the 3D machine model, including the effects of cycle commands and special codes, is as complete as is normally needed in a machine tool simulation. We call this controller-driven simulation to reflect the use of the real controller software, all in NX. Of course, we are still using the G-code output of the NX post-processor for that machine tool. This option for Siemens-controlled machines is available as an add-on to NX-CAM. It is called the VNCK option, referring to the name of the controller core software, the Virtual Numerical Control Kernel. In this short presentation, we introduced the machine tool simulation that's available inside NX-CAM. This is often referred to as the Integrated Simulation and Verification, or ISV option. The basic toolpath verification element is typically provided as standard with all packages of NX-CAM software. Many NX-CAM software packages also include the full machine tool simulation option. It is also available as a low-cost add-on to an existing NXCAM software license.